This is the big tower building, so you can see the SMOB right here. But this is the 14-story Goliath. This is Kaiser's flagship hospital. I was basically a field or a production superintendent for 3 years, working with my hard hat, with my boots on, walking nearly 1 million square feet when you add in the auxiliary support SMOB every day, working with the field superintendents, working with the foremen, really implementing this system to better manage this project. It's a huge facility, 350 beds, very big. It's going to be one of the leading facilities in California, and it's a very beautiful hospital, and it's an amazing experience to be able to work with these guys. All right. So a little bit of process. We collected actuals on a weekly basis. We had 3 sources. We used the data provided by subcontractors to us in their field reports. We used the observations and the provided data from our field superintendents and foremen. And then I also walked the site on a daily basis to create and collect these actuals and create these reports. The technology we used was Vico Office, Cost Planner, Schedule Planner. We used a bit of Excel as well. And we exported this data to Primavera to satisfy the contract to the owner. I will go back to the people here are what really made it. It was the teamwork and the environment. We got all together. We created the reports that were used to manage, that were used in the subcontractor meetings. It was all about the group sessions and agreeing on implementing something that we're going to go through in a moment, control actions, and reviewing something else we're going to go through in a moment, the control plan altogether. So what our client has learned, and really they kicked butt. I can't express how much they really put into this and really pulled it through. But they learned a new style of managing. And I think that by being able to look at it in a flow line environment gave them a much more visual and kinetic method of understanding this project. We were able to leverage the coordination models as a source of information to create our schedules. And we could be proactive by using pool planning and the project team as a whole to correct production and deviations. And the aim of this was really managing the production rate as much as managing our milestone dates. So not just managing dates, but really managing that production. Some of the key benefits was being able to be proactive. We were reporting out in some projects as much as, in some phases of the project as much as daily, as opposed to the monthly CPM requirement. So, really focusing on daily, but usually about a weekly reporting structure. Emphasis was tracking and monitoring work installed, people in locations or resources in locations, and creating detailed documentation. All right, some quick definitions. Control action, and this is our response or our observation of a production alarm. And this is really a proactive mechanism, and we'll show you an example in a moment, that is caused by the generation of a forecast. So we can see that future forecasted performance. How is that going to impact our schedule? How is it going to benefit our schedule down the line? The analysis tool that we use to remedy a control action is called the control plan. Within the control plan, which is a tool within the software as much as it is a discussion point with our field team or with a field team, is that we look at different ways of trying to mitigate a control action or mitigate that production alarm. What can we do? Can we assign some more overtime? Can we assign some more resources? Can we decrease resources? All of these become valid talking points as you're trying to work through a solution to a control action. All right, another flow line example here. Now we're moving to the interiors phase of the hospital tower. We start at lower level through level 12. You'll notice that lower level to level 3 has 4 project locations, and that's because of the floor template, which included another auxiliary building, not the small, but another auxiliary building attached to the tower. As we move through the upper levels from 4 to 12, the floor plate is then split in half. So this is real project data again, and we're looking here at that fireproofing task. So when I put in the data date here signified by this red line. I made it nice and bold. So you can see the 14th of March 2011. We can see that we've started to include some actuals here. But what's most observant to us, or what we can observe the most here, is the difference between this thick planned line and this dashed forecast line. So based off these actuals that we've recorded, we can see that although we started early, for some reason, we're still generating a 3.5-month forecasted delay to fireproofing. So when we start to zoom in, when we really look at what's going on with the actuals, and it's again a very visual process, we can see that we started early in level 1, area 1, but the slope of our actuals line is not close to the slope of our plan line. So that's why we're generating this forecast. That's why we're generating this very pessimistic forecast. So when we introduce that downstream fire sprinkler task, and we know it's coming, we start to see some variability, some discontinuity here. And that's when we can implement, or that's when the software will generate this alarm. And so what we can simply do is, from that data date, count the number of weak bars to where that alarm is occurring. So we can see that it occurs on level 2, area 2. That's when the disturbance is forecast to start if we continue to operate the way that we're operating. And we now have 5 weeks to respond. So we have a little bit of a time in our purse here. So this is a report produced in Production Controller. And this is called the completion report. And this is a metric report that allows us to see, in this example, what our target was for our production rate on a daily basis. So if we look at our fireproofing, we were aiming to achieve 2,000 square feet of fireproofing every day. When I input the actual, we can see that we're not achieving 2,000, we're achieving 1,360 or 1,364, thereabouts, square feet per day, giving us a delta of nearly 636. So when I brought this to the attention of General Superintendent Nels, said, Nels, we've got an issue here. We're forecasting some discontinuity. We've got to solve this. What's going on? I said, well, what are we looking at? And I said, well, we're seeing that we're only installing 1,300 square feet a day. We need to hit 2,000. Otherwise, we're going to be off point here. And that kind of recognized, that jolted something in Nels' brain. He's a seasoned professional. He's been doing this his whole entire life, and this is what his gut was telling him. And he's now seeing this on a piece of paper in front of him. He's seeing the forecast, the visualization of what that impact might look like, but he's getting hard data. He's seeing, we wanted 2,000, we're getting 1,300. What's going on here? So we started to do some root cause analysis. Started to call the fire protection guy. We started to call the fireproofing guy. And what we found out was they were doing some 3D laser scanning for beam deflection on some of the lower floors, and they were pulling the second production fireproofing gun away. We planned to have 2. And so that resulted in that second gun operating at a 50% capacity. So, we couldn't have that. We were going to miss our schedule. And so we decided that we needed to implement a third gun. And fortunately, there was actually a third gun out on site. So that's when we brought the project management team into the room. We started to have a little bit more of a level-headed discussion about exactly what are we going to do to correct this. So part of this process is what we call the control actions log. And this is where we start to document all of our observations and our recommendations and if they're accepted or rejected. So on this time, we made a control action recommendation that we observed 2 guns operating at 50% capacity because of the pickup work, and this was impacting their production rate. So our recommendation to the project was that we would deploy a third gun and focus 2 on production work only and have that third gun do the pickup work. As a result, it was accepted. And our response was, yep, we deployed it. We're going to get those 2 guns as we said we would and allow that third gun to focus. And really, this is something that was simply given to our client in the OAC, the owner, architect, contractor meeting. And it could be a talking point, and they could see that we observed something, and we found a resolution, and we implemented it. So as a result of that, and about 3 weeks later, so we're now in April here in 2011, we were able to align our production rate again and look at that in magic, we're back on time. Well, magic more like hard work. But as we all know, construction is never that easy, and it's a week-to-week fight. And so when we started to track the fire sprinkler guy, we could see that he was really kicking some butt out there on site. You can see that from the slope of the actuals here, beating slope of the plan line here. But what was more observant is that if they continued to kick so much butt, we had 9 weeks to respond before they ran out of work. And this is a little bit embarrassing, but I remember when I was in this OAC meeting, the owner architect contractor meeting, and I was 25 at the time, young guy, and these are all, these guys have been doing this stuff for 30 years. They are, cream of the crop, best in the industry, guys putting together this landmark hospital project. And I walk in and I say, I've observed a deviation in production. We have 9 weeks to respond. Our fire sprinkler guy is actually going so fast that he was going to run out of work. And when I said that our fire sprinkler guy is going so fast, they just laughed me out of the room. And it was, anyways, it wasn't a blow to my confidence so much as I could prove it because I had the data. And that's what it was all about to me. Production rate here, our negotiation with the with our fire protection, the fire sprinkler crew, project manager, was that we were going to hit 436 linear feet a day. But what we were really hitting was 560. So we were installing 124 extra linear feet a day. No wonder they were kicking butt. They really were out there installing the work. They were getting it done and doing a very good job of it. When we pulled the fire protection guy in, project manager Bob in, and said, this is what we're observing, he started to observe the same type of production deviation to his own work. And so again, we came back to the control action log. We logged that we had observed this deviation or this potential impact down the line, and we wanted to make sure that we could provide Bob's crew with continuous workflow. So our recommendation was to reduce the crew by 1 journeyman, and that would allow that crew to flow more freely through those locations without any hindrance or potential impacts to running out of work down the line. It was accepted, and as a result, we could align our production rate, and we could live to fight another day on KPOMC. So now that this project has been wrapping up, we started to do a little bit more analysis about the control actions and where control actions taken in response to production alarms and how effective were they, and so on and so forth. We captured, overall, I think we're going to capture about 300 control action recommendations on the entire project. At this point, we're looking something more like 230. But our most consistent control action was to add resources to lift our production rate to a place where we needed to get it. One of the other ones that we observed the most was closing locations of work 100% before starting a new location. And so again, that's to minimize those blowfly effects or flatlining effects that you saw on QVMC as part of that ASAP management style. And starting work, opportunities to actually get a location going a little bit earlier because we were so far ahead in other locations because of the workflow that we were able to generate. So again, not just looking at the negatives, but finding some opportunities as well through this process. Another thing that we looked at is, did these control actions help in controlling production rates? And some of this stuff was very interesting, very telling. So you can see that the blue indicates a positive increase in that production rate, where the green is negative and this red was no change at all. So when the project accepted a control action, we saw an increase in production, so what we're aiming to achieve, more than 50% of the time. Alternatively, when an action was rejected, we actually saw a negative, so we had an impact to the project. We didn't see a production increase with the appropriate control action. And of course, what was most telling was that when nothing was done, well, we didn't really see much at all. Now we're looking at KPMC Tower, so you can see San Francisco in the horizon here, and the Bay Bridge, and the tower project here, and here she is in all her glory. Learning a new process and management system. That's what this resulted in. A tremendous part and a huge effort by the entire project team to really learn a new process that they were going to implement. Implementing building information modeling, not just for clash detection, but for 5D quantity analysis and for true 4D management and production control. Understanding that if we have so many quantities to install in a week, based off our BIM model, based off our 2D documents, and we only install so much, what does that forecast look like? That allowed us to be proactive. That allowed us to observe production deviations up front. That really gave the project team the tools and the metrics to manage production rates, but also make sure that we maintained our milestone dates as well. The backside of this is detailed documentation that was able to be delivered across the project team, and a weekly reporting structure to facilitate the use of those documents, and how important that was, and like I said, being proactive